Hello, in this video, I will show you how to perform confirmatory factor analysis using Mplus. As an example, you use an article from the organizational behavior literature um, published in Journal of Applied Psychology, which is the top journal in organizational behavior. Um, and it's a very good article. It's a scale development and validation. Very careful with all the steps in describing details. Um, you notice that the way the authors talk about validity is a little bit different on how you talk about it in education. And we get to the chapter about validity, you see how they're using a conceptualization of validity. Any education we have use a newer conceptualization of validity, but it is excellent article. So they develop a scale for voice behaviors, and they find evidence of validity for four factors: supportive voice, constructive voice, defensive voice, and destructive voice. So it's organizational voice, right? And um, so this is the main model. We started by fitting this model. In the paper, you see that they fit some alternative models, like a two-factor model, a couple of different two-factor models. Now, I will fit also some models that they did not fit, which is a higher order factor, where I have the first order factors are these four, and then I have a second order factor that's just called voice, and these four factors load on voice. And I also have a bifactor model where there are four factors, and then there is an additional factor that loads on all items, also called voice. Those are not actually considered by the authors, but I will show them to you. Um, I'm not using real data, I'm using data simulated from their results. Okay, so switching to Mplus, here I have mains CFA by mains CFA.imp. Okay, so file is mains data one.dat. There are 20 variables, so there are 5. In this particular case, there are 5 indicators for each of the 4 factors. I'm using here very basic code, which means that most defaults are kicking in Mplus. So for example, I put the variable command and just the names, but I don't have a use variables statement, meaning I'm saying that I'm going to use all the variables. I didn't put an analysis statement saying which estimator I'm using, and which means that the default kicks in for maximum likelihood. I'm also not saying that I have categorical variables, meaning then that the default is that all these are continuous. And indeed, like I simulate them as continuous. The actual mains and Botsakov um, paper, um, the actual indicators have a Likert scale, but here I have continuous items. Now, the model for a confirmatory factor analysis uses the command by, which stands for measured by. So the general syntax is the name of your factor by the indicators. This reads as support measured by V1 to V5. Okay, now when you set up the measurement model for a latent variable in structural equation modeling, you need to set a constraint to provide the scale of the latent variable. And the options are set the factor variance to 1 or set the first one of the loadings to 1. Now, Mplus by default wants to set the factor loading of the first indicator to 1, right? And here I actually overrode that, it really makes no difference, but I like to set the first factor loading to 1. It makes no difference because model fit is exactly the same, and standardized estimates are exactly the same. So the way you set the scale by either setting the first one of the loadings to 1 or the factor variance to 1 only affects the unstandardized parameter estimates, but not the standardized parameter estimates. Okay, so here, this star here means that I'm freeing the first factor loading to be freely estimated. So if I had deleted this, Mplus would set the factor loading of V1, which is the first indicator, to 1. Okay, so this star is completely optional. It was my choice to free the first factor loading. Instead, then, what I had to do is set the variance of the factor to 1. So support at 1 is setting the variance of the factor at 1, right? So, and I do that for the other factors: construct, defense, and destruct. So here I have 4 factors measured by 5 indicators each. And then after that, I have the 4 variances. So if I delete, I could delete these 4 variances that are being fixed to 1 here, but if I did that, I would have to, by default, fix one of, or allow Mplus, right, to fix the factor loadings to 1. Okay, I'm asking for standardized results. Tech1 just gives parameter numbers. Is only really helpful for simulation studies. And model indices give modification indices. So I'll run this, and let's look at model fit. So the model fit is excellent. So here I have the chi-square test of model fit. The value of the chi-square is 159, degrees of freedom is 164, the p-value is 0.588, so it's not statistically significant. Therefore, this model has exact fit. Not surprised, because I simulated the data, right? So the root mean squared error is 0, CFI, TLI both 1, showing close fit, so excellent. Now let's look at the parameter estimates. So these are the unstandardized parameter estimates, followed by the standardized parameter estimates. So I will skip to the standardized parameter estimates. So the statement support by measured by the indicators, the estimates are factor loadings. So note that all of those standardized factor loadings are, above 0.7. They're all close to 0.9. Excellent, very strong factor loadings. This means that, if I get a factor loading square it, I get the percentage of variance explained. So, these all are very, very strong factor loadings for all of them. And then I have here the correlations between the factors. So I didn't put these statements in the command, in the syntax. I could have, construct with support, defense with support, means correlated with. Now I didn't put them there because Mplus by default estimates correlations between latent factors. Okay, so I could have stated them explicitly, but I didn't need to, because since it's a default. So I guess it shows that they all correlate significantly, except destruct with construct, which do not correlate significantly. Now, and these are the intercepts. Intercepts are not that interpretable, so we usually not even reported, because the CFA model is the indicator equals the intercept plus the factor loading times the factor score plus error, right? But the intercept is not very interpretable. It just means, what, it's like a regression, right? So this is the value of the the indicator if the factor is 0. But the factor has an arbitrary scale, so a factor of 0 doesn't mean much. Usually factor is scaled to have 0 equals the mean of the individuals. So intercept's not very interpretable. Now the factor load is what's most important here, because the factor load is the correlation. The standardized factor load is the correlation between the item response and the factor. So these are very strong. You want them to be at least 0.7. Now, have the variances, which I fixed to 1, so they're not fully estimated. And here the residual variances. Now note that, I'll show you. So we have another standardization here. We don't care about the STD, SDY, which is, so let's just respect with Y. Skip that, STD standardization, skip that. And I squared. So the I squared here is the square of the standardized factor loading. And note that the I squared plus the standardized residual variance sums to 1. So the standardized residual variance is 1 minus I squared. And the I squared is the square of the standardized factor loading. Okay, so these, going back to I squared, we want the average variance extracted, which is the average of the I squares, to be at least 0.5, which means the factors account for at least 50% of the variance. The rest is, on average, the rest is error. But we don't look this across all items. We look per factor. So for example, we want V1 to be, the I squared of V1 to be 5, to be on average at least 0.5. This is, because, the remaining is error. So if you're not at least 0.5, it means that there is more error variance on average than that is explained variance by the factor. Okay. Now these are very high, so this is really good. Okay. Now modification indices are here, but the fit is so good we don't need to look at them. Okay, so now I'm going to switch to a variation, which is the hierarchical model. So in the hierarchical model, I have the same model. I switched though how I scale the latent variable. Now I set the first factor loading to 1, and I freely estimated the factor variances. Now these become residual variances because now I have a second order factor called voice that's measured by the first order factors. So I have here voice measured by support, construct, defense, and destruct. Note that for the second order factor, I freely estimated the first factor loading and I set the variance to 1. Okay. So the second order factor has 4 indicators. Let's run this. And you can see that the fit is also exact, right? And now, so the way to distinguish between the first model and this model is really based on theory. Is there any justification to believe that there is a second order factor, like a general voice factor underlying the other factors? I mean, you could compare them statistically with information criteria, because information criteria measure parsimony, and so the two models could be compared that way. So for example, the Bayesian information criteria of this one is 6550, and in the previous one it was 6541. So the Bayesian information criteria indicates that the simpler model without the second order factor should be preferred, right? But theory should take precedence here, and it's if you look at the standardized results here, um, it's hard to distinguish from a statistical perspective because these like loadings are excellent. I mean, I wouldn't expect them to be affected, but now we have the second. So we have the first order loadings, and we have the second order loadings, and um, they are excellent. Well, the first order loadings are excellent. Um, the the second order loadings are standardized loadings are not as high. They're high for supporting construct, but not for defense and destruct. So in this second order factor, you can notice that there is an interesting, um, because these first two have like a positive uh, aspect to them. The second two don't, like they are more of a negative. You have negative factor loading. So voice, the supporting construct have a positive relationship with voice, defense and destruct have a negative relationship. But again, whether you would keep this model depends on theory. I mean, it fits well, uh, but you know, doesn't mean that this makes sense from a theory perspective. Now let's look at another alternative, um, which is the bifactor model. So the bifactor model is different from a hierarchical model because now, there is four specific factors: support, construct, defense, and destruct, and one general factor. And the general factor is uncorrelated with the specific factors. Um, so this is saying, there exist four types of voice, but there is also a more general type of voice. Let's run these. And again, it fits extremely well. The chi-square is not significant, showing exact fit. Now, the factor loadings, let's look at standardized factor loadings. We have here very high standardized factor loadings, but they are affected somehow because look, now the defense factor loadings are not as high as they were before. And now we have the loadings for the voice behavior. Note that they are not high. They are higher for defense. And I think what happened is the defense had an aspect that was common with the others. So like now the items are loading stronger on this general voice factor that's shared with the others, but less on the specific defense factor. And then there is an interesting pattern here. Now notice that most of these factor loadings are not statistically significant. So this doesn't support these very well, only the defense loading. So it shows that model fit is really not the sole reason to choose a model. Like you have to justify it from theory, and there are other aspects such as are the factor loadings even statistically significant? I mean, these are not. So I think I'm getting some very small correlations here between, but it's doesn't seem very meaningful. So this doesn't seem to. I don't think it would make sense from a theory perspective, but that's how you fit a bifactor model. That's the example. Okay.